Next question. Is f of x is equal to 5x if x is lesser than 1 and 2x plus 3 if x is greater or equal to 1, continuous and differentiable at x is equal to 1? Let's check. First, let's check the continuity. At c is equal to 1 or x is equal to 1, that's f of 1, or that's f of 1 is equal to 2x plus 3 or 2 times 1 plus 3, which is according to our piecewise function. We will use 2x plus 3 if x is equal to 1. So the f of c is equal to 5. Next is the limit of the function. So we will evaluate the limit from the left side and from the right side of the function. In this case, from the left side, we will use 5x. So the limit of f of x as x approaches 1 negative, or limit of 5x as x approaches 1 negative is equal to 5. Next is from the right side. The limit of f of x as x approaches 1 plus, that's limit of 2x plus 3 as x approaches 1 positive. So 2 times 1 plus 3. So we will use 2x plus 3 if x is greater than 1, which is equal to 5. We can see that from the left side and also from the right side, our limit is equal to 5. Therefore, the limit of the function is equal to 5. And we can see that the f of c is equal to 5, and also the limit of the function is equal to 5. Therefore, it also satisfies the third condition. Therefore, our function is continuous at x is equal to 1. Okay, so we knew that our function is continuous. But how about the differentiability? Is it differentiable at x is equal to 1? Let's check. Okay, just like in the case of a limit, to check the differentiability of in a piecewise function, we should check the left side derivative and also from the right side derivative of the function. So if our x is lesser than 1, we will use the 5x to get the derivative of the function. If our x is greater than 1, we will use the 2x plus 3 to get the derivative of the function from the right. Okay, let's start from the left. For x is lesser than 1, so we will use f of x is equal to 5x using the alternative definition of the derivative. So the limit of f of x plus h minus f of x as x approaches 0, negative. So using the function 5x, so it becomes 5 times x plus h minus the function 5x all over h as h approaches 0, negative. Okay, 5 times x plus h, that's 5x plus 5h minus the 5x, so 5x minus 5x is 0. So 5h over h, we could simplify this one. So the limit of 5 as h approaches 0, negative is also equal to 5. Therefore, the f prime of 1 from the left side is equal to 5. Next is for the right side. If x is greater than 1, we will use 2x plus 3. So using the same equation of the derivative, so the limit of the function now, 2x plus 3 is 2 times x plus h plus 3 minus the 2x plus 3 all over h as h approaches 0 plus. So 2 times x plus h, that's 2x plus 2h plus 3, and then minus 2x and minus 3 all over h as h approaches 0. So 2x minus 2x is 0, 3 minus 3 is 0. So 2h minus h, so we could cancel this one. So the limit of a constant is the constant. So the f prime of 1 is equal to 2 from the right side. We can see that the derivative from the left side is different from the derivative from the right side. Therefore, it doesn't coincide. The limit at x is equal to 1 doesn't exist. And it also means that for the definition of the derivative at x is equal to 1, we can conclude that the function is not differentiable at x is equal to 1. So, no, it is continuous but not differentiable at x is equal to 1. So we can see that on a graph of the function that at the point x is equal to 1, we can see that the function is continuous there. However, we can see that there's a sharp corner or a cusp point there. Therefore, it's not differentiable. According to our previous topic, that for a point that has a sharp point or a cusp corner, it means that there are um, different value of the derivative from the left side and also from the right side at that point. Therefore, since there are different values from the left side and from the right side of the derivative, therefore there is the real value of the derivative doesn't exist at that certain point.